Okay, so we're just looking at a video for volumes of revolution. Volumes of revolution. Let's put that word up there. Volumes of revolution around the y-axis. So the formula is, previous one was volume equals pi y squared dx around the x-axis. And so the formula for the y-axis is pi x squared dy between the two boundaries. So if we're rotating around this way, so we're going to form some sort of shape. Okay, it'll just be between A and B, and as long as we've got the formula here in terms of x equals, we can square x and we can integrate that with respect to y. Okay, so what are the complications? Okay, there are no complications if the area we want is right up against the y-axis. So for instance, if this is y equals x plus 1, rearranging the formula, x equals y minus 1. So the volume of revolution, so we're rotating around this way to form a cylinder of some sort. So it's between 1 and 3 y minus 1 squared, because we've still got if x squared, then we square that side. And then this is a linear function, so I just add 1 to the power, divide by the power, and divide by the derivative of the bracket. And then I just sub it in, and I get 8 pi on 3. Now I'm going to use this answer later on in another question. Okay, so just copy that and come across. Okay, what are the problems we can get? So what happens when the area is not up against the x-axis? So that we don't have an area here, we've got the area down the bottom. Okay, so we need to consider this as two volumes and subtract. And the two volumes will be this larger volume that I can rotate around the x-axis and this smaller volume, and then I'm just going to subtract. Okay, so we've got to think about subtracting volumes. Okay, so here I've got this y equals x plus 1. Okay, so the larger volume is this cylinder. Yeah, I'll just put it in pink. Okay, that's just a cylinder, so I'm rotating around this way. And so the radius is 2 and the height is 3. Okay, where do I get the height of 3? Well, I just put 2 plus 1 and get the height as being 3. Okay, in case you're worried about that. Now, I don't use calculus. I just do volume equals pi r squared h. So you don't use calculus for the simple things. And for the smaller volume, we did this question before, 8 pi on 3. And so the actual volume, which is this shape, being rotated around the y-axis, is the cylinder, 12 pi, minus the bit we cut out, and we get 28 pi on 3. Okay, so copy that and we'll look at some harder examples. Okay, so we've got a curvy shape, and this one is a little bit harder. So when I looked at it, I've got a large cylinder there. Okay, so I've got R is 4, H is 2. Again, I just put these numbers in so I can get these two numbers. So if it's square root of x, square root of 4, and square root of 1 gives you the height there. So the big cylinder, which is there, gives us 32 pi. Now, the little cylinder is just there. So I've got R is 1, H is 1, so I get pi. So I'm going to subtract. So at the end of the day, this shape here will be getting rid of this shape and getting rid of that shape. Okay, so I've got a large cylinder to start with. I've got a small cylinder. Now, the only complicated one is this one, part 2. So it's between 1 and 2. So I'm actually calculating this now. So I've got pi between 1 and 2. Now, I've got to rearrange the formula. So pi equals root x squared, x equals y squared, and I have to get x squared in the formula, so I end up with y to the 4. And then y4 becomes y5 over 5, and then just move the 5 out the front between 2 and 1, and then just use the calculations and get that answer. And so the final volume equals the very big shape minus the two smaller shapes, and I end up with 124 pi on 5. Copy across, we've got another 2 examples to go. Okay, so again we've got this next one, sorry. So we've got y equals 2 on x, so x equals 2 on y. And so this one here, first of all, I started with, okay, so these two numbers here and here just come from substituting 1 and 3. So when I did it, I had this little cylinder down the bottom. So R is 3, H is 2/3, so volume equals 6 pi. Then I thought about a smaller cylinder there, which I can subtract, which will end up giving me that one here. So R is 1, H is 2/3, so I end up with 2 pi on 3. And then I'm still trying to get other shapes, so I've got another shape, which is a cylinder here. So R is 1 and H is 1 2/3, so that's going to be another volume just there. And so the last part is this complicated shape. I need to get this shape here, but I've got to get the whole shape. So I'll end up with this shape plus this shape minus that shape and that shape. Okay, so this complicated shape is 2/3 to 2, 2/3 to 2. X squared is just 2 over y squared. 2 over y squared equals 4 to the minus 2, which becomes, when I integrate, minus 4 over y. So I end up with 4 pi for the whole shape. Okay, that shape there. So the final volume equals, I start off with a big cylinder, okay, which was that whole shape. I then minused a little cylinder. I minused another cylinder, which was just there, and then I added the complicated shape, which was 4 pi, so I end up with 8 pi. Okay, so that's the way to go. Okay, one more example, I think. Okay, this next one was x squared plus y squared equals 4, so I've got that shape. Okay, and then when I looked at it, so first of all, that's the rearranging of the formula. So when I looked at it, I saw a cylinder just there. So radius is 1, height is 2√3. The √3s came from just substituting in. So that's the volume of the green cylinder. Now, this little bit up the top, okay, is going to be the same as that. So at the end, I'm just going to find one, and I'm going to double it to find the other. So I've got, so x squared is that, so pi √3 to 2 of that area, and then I just keep going through, and I end up with that answer. And so the final volume will be the cylinder plus 2 of these other areas, plus 2 of those areas, and you end up with that area there. Just being careful with the fractions and things like that. Okay, so hopefully that gave you a good idea about volumes around the y-axis. Okay, bye.